Hiya. So in this video, we're going to look at an example of the multinomial distribution. So remember from last video, the multinomial distribution is given by this. I guess I forgot to write this actually. Multinomial distribution is given by this formula. So we have L different events that are happening, and we want to kind of figure out what's the probability of them happening if we know the probability of each one in total. So let's look at an example. So here we're rolling a regular six-sided die, which I guess I forgot to mention. Let me highlight this. So we're rolling a six-sided die. And we keep track of three different variables. So here we're going to look at three options. One of them is the number of even numbers. So here we have two. This obviously has the probability of equal 1/2, right? Half the time we're going to have an even number. The number 1, this gives me the probability of, I guess here we'll do the numbers here, 1/6. And then everything else. So here we have just two numbers left, right? So we've done the even numbers 2, 4, and 6. We've done the number 1, so what's left is 3 and 5. So since there's only 3 and 5 left, we'll say P3, well, it's 2 out of 6, so 1/3. Those are kind of our three different options. And since we're looking at three things here, we know L is equal to 3. Notice how we have this condition that P1 plus P3 is equal to 1, right? So if I add these up, this is equal to 1. So this is a condition that we should probably check and kind of figure this out. So we have our P's. Let's figure out now what the question is kind of asking. So the question is asking, let's look at this. It's asking, if we roll the die 10 times, what's the probability that we get 6 even numbers and the number 1 3 times? Okay, so what's this asking? This is saying, okay, we do 10 rolls, so we know n is equal to 10. We're saying we want 6 of them to be even. So even numbers is done by 1, so what we're saying is k1 is equal to 6. Okay, the next part is saying the number 1 3 times. So here number 1 is 2. So here k2 is equal to 3. And all that's left is k3. So k3 obviously has to sum up to everything, right? So we have, because we have 10 in total. So this is 10 minus 6 minus 3 is equal to 1. So k3 is equal to 1. At this point, we have basically all the numbers, and we just have to plug in. So if I do x1 is equal to k1, x2 is equal to k2, x3 is equal to k3. This is just going to be, so if I look at my formula from above, I'm going to have n choose k1, choose k1, choose k2, choose k3. And then we would have p1 to the k1, p2 to the k2, p3 to the k3. So this thing I might have not forgot to mention last time as well. This is really just the choice function, right? So I choose 3 items, then I choose 5 items, and then whatever is left over is basically my choice of whatever is the leftovers, kind of. And that's why this is the like a multi-choose kind of thing. That's where this is kind of coming from. So at this point, we just plug in numbers. So n we know is 10. Then we have k1 is 6, k2 is 3, k3 is 1. P1 is 1/2, k1 is 6, p2 is 1/6, k2 here is 3, and then k3, which is 1/3 to the 1. And so here we just have to solve. So here we have 10 factorial over 6 factorial, 3 factorial, 1 factorial. And then here on the bottom, I don't know if I did this, but we basically end up having 1 over 2 to the 6 times 6 to the 3 times 3, right? So I just put those 3 fractions together. Here we can kind of do some of this cancellation by hand. So the 6 factorial I can take off from this 10. So we get 10 times 9 times 8 times 7. So all the 6's and they're off are gone. The 1 factorial gives me just the 1, so it's not really doing anything. And on the bottom, I have 3 times 2. So I'm going to merge it into this. So I have one more 3, so I'm going to add 3 squared. And then I have 6 cubed, and then the 2, I add one more, so I have 2 to the 7. So at this point, it's just multiplication and division and stuff. And so putting this into a calculator, you should get 0.20255, as long as I did the number right. And so that gives us a way to kind of calculate this in a very nice, easy way. And as you notice, it's basically just the same thing as the binomial distribution. It's just we're looking at more terms at one time. So more than one thing can happen at one time with different probabilities, which is nice because this is something a little more global in some sense. This is something we'll see in more real life events. So I'll stop here and I'll see you all for the next video about symmetry. See you then.